All right, so we're going to pick up where we left off. We're now going to be solving higher degree equations, ladies and gentlemen. So here's what we do. We're talking about equations that have, it's not x squared anymore. It's going to be x to the third, x to the fourth, and so on and so forth. I need you to see something real quick. Let's do this, just an easy one. X squared plus 5x, let's see here, plus 6. All right. So our positives, if I was using the x method with this, two numbers that multiply to 6 and add up to 5, it'd be 2 and 3. So this would be the same thing as saying x plus 2 and x plus 3. So I'm showing you that so that I can show you what we're going to be doing similar to that. Okay? Let me change this up. What if I had smiley face squared plus 5 smiley face plus 6? Okay, then I would factor it using the same way. Two numbers that multiply to 6 and add up to 5. So I'm factoring, I'm just treating these smiley faces as if they're the x variable here. Okay, so then it would be still 2 and 3. I would have smiley face plus 2 and smiley face plus 3. Okay, now what if I told you that smiley face was equal to x to the fourth? Okay, then I would substitute this in wherever I see a smiley face. So it would be x to the fourth plus 2 and x to the fourth plus 3. Now, I just totally made this problem up, but it's kind of similar to how we're going to be looking at the next couple of equations because, ladies and gentlemen, here I see x to the fourth and x squared. Now, what I was thinking of a way to explain this to you, and it's like a stuntman in a movie. Like you got the star that's starting the show, but when it comes to something dangerous, they plug the stuntman in for the stunt, and then after that, they put the star back in. So here, if I looked at this and said, okay, well, I'm going to say that x squared is the same thing as triangle, okay? Then this is a triangle here. All right, so the triangle is my stunt guy. Now, x to the fourth is the same thing as x squared squared. So this is the same thing as triangle squared. So I'm going to look at this and say, okay, well, I can factor something like this because this looks very similar to x squared minus x minus 72. Now I can factor that. So if I did this, it would be, let me change the color here. All right. It would be, let's see, two numbers multiplied to negative 72 and add up to negative 1. That'd be 8 and 9, but I'd make the 9 negative. So that would be x minus 9, x plus 8. Okay, so if I know that, I'll go ahead and erase some stuff real quick. If I have this, it factors into this. Great. So now, that means up here, can factor this into, using the triangles, triangle minus 9, and triangle plus 8. Okay. But I don't want to deal with triangles anymore. I want to go right back to what it is. Now, every time I see a triangle, I can put an x squared. So instead of that, it's x squared minus 9 and x squared plus 8. Okay. After that, this is a difference of squares. It can still be factored. X plus 3, x minus 3. Then I have x squared plus 8 over here. Now, that was a big leap. Going from here to there is a big leap. Let me go ahead and explain what I would do. I'm just going to erase everything right now and not use the triangles because it might be easier just to show you this. What I'm going to do is I'm going to factor this using the x method. So negative 72, negative 1. Hopefully you didn't quit on me. Hopefully you're still with me. Let's just imagine this is just x squared minus x minus 72. And factor that. So this would be negative 9 and 8. Okay? So if I were factoring this, I would have x minus 9 and x plus 8. Once again, this is still equal to 0. The problem is x times x is x squared, and I have an x to the fourth right here. which means we can't do that. It doesn't work. But if I make those both squares, now it does. X squared times x squared is x to the fourth. That'd be negative 9x squared. This would be 8x squared, and then make negative 1x squared. So that would work if I just factored it normally and just put a squared on both of them instead. That's maybe what you should do, okay? Try that method. But then we keep going. This is x plus 3, x minus 3, and I have x squared plus 8. That doesn't factor. It's not a difference of two squares. It's not a difference because it's addition right there. Now we can get some solutions. And now is when we set each of those equal to 0. So x plus 3 equals 0. X minus 3 equals 0. I'm also going to set this equal to 0. X squared plus 8 equals 0. Now I'm going to get all the solutions that I can. So I'm going to subtract 3, subtract 3. One of my solutions is x equals negative 3. Hooray. Add 3, add 3. One of my solutions is x is equal to a positive 3. And then here, I'm going to subtract 8 from each side. X squared is equal to negative 8. Then I'm going to square root both sides to get x by itself. Now, a couple things to remember here. Our answer is going to have a plus or minus in it. Anytime you square root both sides with an x squared, you're going to get a plus or minus. Now this is going to go on a little trip here, a little journey, if you will. Negative 4 and negative 1 and 2. Those three things multiplied to negative 8 was the square root of 4. 2 was the square root of negative 1. I was the square root of 2. The square root of 2. So those are all your solutions for number 3. All right, now here's the work that I have popping up, just so you can see what I have. Basically the same stuff. I just had to try and explain it a little bit better there. Now, the first step on number 4, since it's not set equal to 0, once again, this is not 0, we have to get rid of that. We're going to add 20 to both sides. Then, this one I'm going to factor just like I did there. Like, let's imagine that it was just x squared and x for here and here. That would mean what two numbers, it's an x method problem, what two numbers multiply to 20 and add up to 9? Well, that'd be 4 and 5, both positive. So then this would be x plus 4, x plus 5, still set equal to 0, but I have to remember that's x to the fourth. So I'm going to make those both squares. If I make them both x squared, then that'll get me x to the fourth. All right, and now I set each of these equal to 0 and solve. They can't keep factoring. Neither one of them are differences of two squares. So you can't keep factoring. You just have to set them equal to 0. So x squared plus 4 equals 0. And x squared plus 5 equals 0. Subtract 4, subtract 4. X squared equals negative 4. Square root both sides. X is going to equal plus or minus. Can't forget that. And then the square root of 4 times negative 1. Square root of 4 is 2. The square root of negative 1 is I. So plus or minus 2i. Similarly here, but it's going to be a little easier, we subtract 5 from both sides. I get x squared is equal to negative 5. Then I have to square root both sides. Now, whenever you square root, you end up with an imaginary number. Whenever you square root a negative, you end up with an imaginary number. So here's what we hit. If I have the square root of negative 1 times 5, the square root of negative 1 is I. The square root of 5 is just the square root of 5. So the other answers are plus or minus I root 5. All right, so you can pause that there. Either way, here's the work associated with that. All right, and there's there for you to look at. And let's see here. I'm going to go ahead and pause and put this other stuff on another video.